that's this kind of example. So let's continue on to the next page. So the examples on this page are a little bit more complicated. Because I mean, before, the simplification basically comes from a single cancellation, but on these examples, it might not just be a single line cancellation. But in any case, let's see what we can do. So looking at example E, so what can we do? We have a tangent and we have a cotangent. So if you're not sure what to do, you can follow what we did in the previous page and then write things in terms of sine and cosine. And it's possible to do it for this example, right? So like you would use tangent, you would use this one, and then cotangent, you would use this one, and then everything will be in terms of sine and cosine. And it's possible to do it that way for this example. However, if you're writing things in terms of sine and cosine, things become a little bit more complicated, and it might not be so easy to simplify things from there. So to make things a little bit easier, we can try to look for some other identities we might possibly be able to use, right? So the two trig functions here are tangent and cotangent. So you can ask yourself, is there an identity that relates directly these two trig functions? And there is, right? Because cotangent is just the reciprocal of tangent. So we can use that identity instead. Okay, so let's use the fact that cotangent is 1 over tangent. Okay, so let's write it out. So what do we have? The numerator stays the same because it's already tangent. And now I can write the denominator in terms of tangent. Okay, so now I have 1 plus tangent over 1 plus 1 over tangent. So everything is in terms of tangent, and now I have to simplify this thing here. Okay, so what can I do? So I have a fraction inside a fraction, so I can look to find the common denominator. And the common denominator, there's only a single denominator, right? So tangent, so that has to be the common denominator. So I can cancel the denominators by multiplying the top and the bottom by tangent. Right, so I have to multiply both the top and the bottom by tangent because to keep everything equivalent, whatever you do to the numerator, you also have to do to the denominator. Right, so I multiply the top by tangent. I multiply the bottom by tangent. Okay, and then I have two things in the numerator and two things in the denominator, right? So I need to distribute. So what do I get? So tangent times 1 is tangent. Tangent times tangent is tangent squared. Okay, because something times itself is just that thing squared. Tangent times 1 is tangent. And then this is tangent over tangent, so that cancels out to just 1. Okay, so I have this thing. And now how can I continue from here? Well, in the numerator, I have a tangent in this term, and then I have tangent squared in this term. Okay, so since both terms contain tangent, I can factor out tangent. So what do I get? So basically there's a common factor here and here. Right, so I factor out the common factor. So if I factor out tangent, there's one left over here, and there's one more tangent left over here. And then, what is the denominator? Tangent plus 1. But 1 plus tangent and then tangent plus 1 are the same thing, right? Because when you're adding two things, it doesn't matter which order you add them in. So this is the same as this, right? So they just divide each other out. And what am I left over with? Just tangent. Okay, so now it's just a single trig function. And so I am done. I mean, you can write it as sine over cosine, but that's not completely necessary. Okay, so that's example E. So I mean, in the end, again, we only really need one identity where I can relate cotangent to tangent using the reciprocal identity, but then the process to simplify things becomes much more complicated. So you might have to use different algebraic tricks to try to figure out how to simplify it. Okay, so any questions on example E? Okay, so looking at F and G, I see I have the square of the trig functions, right? So this is where I want to look at the Pythagorean identities. Okay, so what Pythagorean identity do I have for secant squared? So what do I have for secant squared? I have this identity, right? So secant squared is equal to tangent squared plus 1. So secant squared x is equal to, again, tangent squared plus 1. So this goes in here, right? So what do I have? So tangent squared x plus 1 minus 1. Right? So this plus 1 and then this minus 1 over sine squared x. Oh, this should be in blue. Okay, so plus 1 and minus 1, that cancels out. So what am I left with? So tangent squared over sine squared. And then now I've still have two trig functions, right? So tangent and sine. So how can I relate tangent and sine? Well, tangent is sine over cosine, right? But it's tangent squared, so you can just square everything, right? So tangent squared is sine squared over cosine squared. Okay, so now I'm using a second identity. So this will go into the numerator. So what do I have? Sine squared over cosine squared over sine squared. And again, dividing by something is the same thing as multiplying by the reciprocal. Right, so you have sine squared x over cosine squared x times, right, so reciprocal of this, right, so this is over 1, right, so reciprocal of this is 1 over sine squared. And what am I left with? 1 over cosine squared. Kind of running out of space here. Right, so 1 over cosine squared. But what is 1 over cosine squared? Well, 1 over cosine is the same thing as secant. So I'm actually using a third identity here, right? So 1 over cosine is using that 1 over cosine is the same thing as secant. Okay. So let me not confuse it with the other one. Okay, so that's example F. And so basically, I mean, you might have to just continue looking for different identities until you can't simplify the expression any further. But again, there's no real general procedure that tells you which identities you should always use and so on. Okay, so let's finish up the last two examples. So here I have cotangent and cosecant. Right, so cotangent and cosecant. But squared, right? So cotangent squared and cosecant squared. So there's this last identity. 1 plus cotangent squared is equal to cosecant squared. So let's use that. Right, so what am I using? So cosecant squared x is equal to cosecant squared is equal to 1 plus cotangent. Right, so this thing, this is going to go here. So let's write it out. So cotangent squared minus this thing, but this thing is replacing a single thing, so I need to put in parentheses here. Plus cotangent squared. And then now this distributes. So what do I have? Cotangent squared minus 1 minus cotangent squared. Then this thing minus itself, so that cancels out. So I'm just left with minus 1. Okay, so that one wasn't too bad. And then finally, the last one, which is probably the most complicated one. Okay, so this one is set up slightly differently, where they're giving you an equation and they're asking you to simplify the left-hand side so that it looks like the right-hand side. And the basic idea is to start from the left-hand side, which typically will be the more complicated thing. So I'm starting from the left-hand side and apply a series of either identities or simplifications, and then the final result should look like the right-hand side. Okay. So let's start off, right? So I have two different trig functions, tangent and sine, and then the final result only contains cosine. So my first thought should be to try to relate everything in terms of sine and cosine, and I can do that with for tangent, right? So what am I using? So I'm using that tangent is sine over cosine. Okay. So, but this is 1 over tangent, right? So that means that 1 over tangent is the reciprocal. So to save some space, I'm just gonna do this in once. So tangent is sine over cosine, but 1 over tangent is the reciprocal, right? So 1 over tangent is cosine over sine. Okay, so that's what I'm using here. Right, so this becomes cosine over sine. Right, so I'm making this substitution into here. Well, into this thing. Okay. So now I have two fractions with the same denominator. So I can just add them together. All right, so what does that become? Cosine plus 1 over sine. And then this whole thing squared. So I have this. And okay, so now where can I continue from here? Well, when you square a fraction, that means you're squaring both the top and the bottom. Right, so what do I have? So it's cosine of x plus 1 squared over sine squared of x. Yeah, so the square just goes on the top and the bottom. And okay, so now I have sine squared in the denominator, but again, the end result is only in terms of cosine. So how can I relate sine squared to cosine? Well, I have the Pythagorean identity. So sine squared is plus 1 is sine squared plus cosine squared is equal to 1. But so that's what I'm going to use. So sine squared x plus cosine squared x is equal to 1. Well, let's just write this in a slightly different form. So sine squared x is equal to 1 minus cosine squared x. So this is going into here. So what do I have? So cosine x plus 1 squared over 1 minus cosine squared x. So I'm almost there, right? So I have this and this. So now how do I simplify this to look like the final result. So in the denominator here, it might not look like it, but what do I have? I have a difference of squares. Right, so how should I think of this? Right, so say I have 1 minus a squared. So this is a difference of squares. How do I factor something like this? It factors as 1 plus a times 1 minus a, right? Where in this case a is cosine, right? So what does this become? So cosine of x plus 1 squared over, right? So I'm factoring it in this way. So 1 plus cosine x times 1 minus cosine x. A is just, cosine is playing the role of a here. And then finally, right, so again, cosine plus 1 is the same thing as 1 plus cosine, because adding is commutative. Right, so I have one copy of this, and it cancels out one copy of this. And then now this thing is the same as the numerator here, and then the denominator here is the same as the denominator here. And so now I'm done. Okay, so this one was a little bit more complicated, but basically you just keep applying different identities and then seeing what kind of simplifications you can do until the final result looks like the thing that you want. Okay, so yeah, so again, there's no general procedure for these kinds of problems. So I mean, there might be some trial and error involved when you're practicing these kinds of problems.
Professor Bo?
Yes.
Could you please scroll back down to the bottom again? I didn't finish. Okay, yeah, I just wanted to make sure I got everything. Okay, thank you.
Yeah, so there's there's no general procedure for these kinds of problems. Just look for different identities that you can use that relates to the various trig functions that you're working with, and remember the various different algebraic tricks that might be involved. Right, so like how to deal with fractions, like dividing fractions, adding fractions, and so on. And then here we have a difference of squares, and so on. Yeah, but again, there's no general thing that says, okay, you should use this trick or you should use this trick. That basically just boils down to intuition that you build while practicing these kinds of problems. Okay, so any questions on this in this section? So again, section 9.1 focuses on these identities, right? So those are the ones that you're looking for. Okay, so if there are no questions on section 9.1, I want to at least get started